Hey guys, welcome back. This is day 5 of algebra. We are solving equations today. So we're going to start with the warm-up, and the first thing we do is a simple one-step equation, but it gets us thinking about solving an equation. Now with an equation, our whole goal is to isolate the variable. And to get the variable by itself, or isolating it, you need to start out by, in this case, you're going to subtract 5 from both sides of the equation. Because the golden rule of algebra says whatever you do to one side, you have to do to the other. You've got to keep it balanced. So 5 minus 5 is 0. Okay, that's the additive inverse property. It causes it to go to 0. And so we're left with just an x on the left side of the equation, and then x is going to be equal to 10 minus 5, which is 5. Okay, so I know with this first example you may have looked at it and said, well, I know that 5 plus 5 is 10, so x has to be 5. But you are actually solving the equation in your head in this way. Okay, you're really subtracting 5 from both sides, doing the opposite operation. So let's try it now with number 2. It's a little harder because now we have a negative number. So in order to isolate the variable x, we want to do the inverse. Instead of subtracting 2, we're going to add 2. Okay, that will force that to be canceled out and go to 0. And a golden rule of algebra says whatever we do to one side, we have to do to the other. A negative 4 plus 2 is a negative 2. So we're left with x is equal to negative 2. All right, so if we did the check step and we took negative 2 and we plugged it back in here, we would get x is now negative 2 minus 2 equals negative 4. And when we figured it out, we would actually do the check step. We'd see that negative 4 is negative 4. So that's how we do the check step. You take the answer and you plug it back in. The answer is still x equals. All right, number 3 is an example of now we're multiplying. So the inverse operation of multiplication is actually division. So in order to isolate x and get it by itself, we need to think of the multiplicative identity property, okay, which means if we took 3 times 1/3 or divided by 3, we would get 1. And 1x is just x. So now we're left with x is equal to negative 21 divided by 3, which is a negative 7. And there's our answer. Again, you can plug it in and try the check step. Okay, number 4 is a two-step. All right, with a two-step equation, we start out and we subtract the constant first. Okay, and we end up with 2x is equal to 6. Okay, now we're going to divide both sides by 2, and we end up with x is equal to 3. All right, if I did my check step, and I'll do it in a different color here for you, this would be 2 times now x is 3 plus 5. Does that equal 11? If you do the work, 6 plus 5, does that equal 11? Yes, it does. Okay, so you know that that's the right answer. Okay, the check step is highly recommended. All right, so what we're going to learn today is how to solve multi-step equations. So we're going to use this kind of silly acronym to help us remember the checklist when solving equations. So the D stands, it's actually DC-MAM, and the D stands for distribute. Okay, the C stands for combine like terms, and these are exactly what we did last week and you had your test on. Okay, M stands for move the variable. Okay, so we're going to move the variable together. We're going to actually get them together, cross the equal sign. I'll show you how to do that. We want to have one occurrence of the variable. Then we're going to add or subtract, and then finally we multiply or divide. All right, so this is how it works. Okay, that's divide. All right, we remember again that golden rule of algebra. Whatever you do to one side of the equation, you have to do the same thing to the other. You've got to keep it balanced. Okay, we're going to use the DC-MAM checklist, okay, to help us remember. All right, so example number 1, we can't distribute anything. Okay, we can't combine like terms because this C for combining like terms means to combine like terms on either side of the equal sign. You don't want to cross the equal sign at this point. Okay, 10x plus 18, you can't combine any terms. 8x plus 4, you can't combine any terms. But this is important. Now we're going to move the variable to one side. So I'm going to subtract 8x from both sides. Okay, so I'm essentially moving it across the equal sign. Okay, so it becomes a negative 8x on this side. 10x minus 8x is 2x. So I'm left with 2x plus 18 is equal to 4. Okay, notice now I only have one occurrence of the variable x. Okay, so you just moved the 8x to the other side and you did it by subtracting. You do the opposite operation, and then you follow the golden rule of algebra. Okay, whatever you do to one side, you have to do to the other. Now, I'm going to add or subtract. So in this case, I've got a plus 18. I'm going to subtract 18. I'm doing the opposite, okay, because 18 minus 18 is 0. So that would cancel out, and I would be left with 2x is equal to 4 minus 18 is negative 14, okay? And our final step would be to multiply or divide by the coefficient. Well, in this case, we're dividing, or we could say we're multiplying by a half. It's the same thing, okay? 2 divided by 2 is 1. So we're left with x is equal to, so funny, x negative 7. Okay, so we got our answer. And if we did the check step and we plugged it back in, we'd verify. Let's try it. Okay, oops, let's not try with yellow. Let's try with something a little bit darker. Okay, 10 times negative 7 plus 18 is equal to 8 times negative 7 plus 4. Notice I'm just plugging it right back into the original equation. Now I follow my order of operations. Negative 70 plus 18 is equal to negative 56 plus 4. Okay, if I add them together, I'm going to get negative 52 is equal to a negative 52. And that's right, okay? So they're both equal. I know that negative 7 is my answer. Okay, so this is considered the check step. All right, so let's try number 2 here. Number 2, I'm going to start out and distribute. I can't distribute anything, but here's an example of combining like terms. Okay, notice on the right side, I can combine the 2x and the negative 5x. So on the left side, we get 3x minus 4 is equal to 2x minus 5x is negative 3x plus 8. All right, now when I move my variable, okay, I'm going to move it to the left. I'm going to add 3x. Okay, when I add my 3x here on the left side, we get 6x minus 4 is equal to, now the 3x, negative 3x and positive 3x cancel out, and we're left with 8. All right, I'm going to add or subtract the constant here, so I'm going to add 4 to both sides. When I do that, I'm left with 6x is equal to 12. And then when I divide by 6, last step, my x is 2. Okay, so then you can plug it back in and do your check step. Okay, moving on to number 3. Okay, we're going to remember our acronym DC-MAM. Only now here's our first example of being able to distribute. So I see I have the parentheses, so my first step would be 2x. Now I'm going to distribute the negative 5, and I get negative 5x minus 5. Okay, so negative 5x, and then negative 5 times 1 is negative 5. That's going to be equal to 3x plus 1. Okay, I'm going to be able to combine like terms on the left side. 2x minus 5x is negative 3x. Okay, and that's going to be equal to 3x plus 1. Now I move the variable, so I'm going to subtract 3x from both sides. And when I do that, I get negative 6x minus 5 is equal to 1. And then I'm going to add 5 to both sides. And when I do that, I get negative 6x is equal to 6. And then I'll divide by a negative 6. My x is equal to a negative 1. Okay? All right, now let's try the next example. And actually, this would be a good time to pause and try it on your own and then come and see if you get the same answer. Okay, but I'm going to actually do the work here. So I've got 3x. I'm going to distribute. Negative 3 times 6 is negative 18. Negative 3 times negative 2x is positive 6x. All right, I'm going to combine my like terms on the right side. And I've got 3x plus 6x is 9x minus 18. Okay, and now I'm going to add 18 to both sides. Okay, notice my variables on the right, that's fine. Okay, when I do that, I get 45 is equal to 9x. Okay, and then I still want x to be by itself, so I'm going to divide both sides by 9, and I end up with 5 is equal to x. Okay, we can also write that as x is equal to 5. Okay, then you can plug it in and do the check step. All right, so I will try 5 and 6. Okay, all right, so number 5, whoops, got too far on that one. Okay, number 5, we're going to double distribute. All right, I've got a negative 12x minus 9 plus 24x plus 4 is equal to 43. Notice, all I did was what we did last week. We're double distributing, okay? All right, I'm going to combine my like terms. I've got a negative 12x and a positive 24x gives me positive 12x. And then I'm going to take a negative 9 and a positive 4, and I get minus 5. And that's going to be equal to 43. I'm then going to add my 5 to both sides. So I get 12x is equal to 48. We then divide both sides by 12, and our x is equal to 4. Okay, and then again, plug it back in and make sure it works with the check step. And I'll show you at the end another way to do the check step, which is kind of nice. All right, so now with number 6, okay, you're going to distribute negative 20x plus 10 is equal to negative 6 minus 12x. Okay, I'm going to move the variables, so I'm going to add 12x to both sides. Negative 20, let me see, add the 12x to both sides. So I'm going to get negative 8x plus 10 is equal to a negative, that's a negative 6. All right, now I'm going to subtract 10 from both sides. So I get a negative 8x is equal to negative 16, so that when I divide by negative 8, my x is going to be equal to 2. Okay, so I want to do my check step. Okay, I'm going to plug in negative 5 times 4 times 2 minus 2, okay, equals negative 2 times 3 plus 6 times 2. So let's make sure that works. Okay, negative 5, this is 8 minus 2. Okay, and that's going to be equal to a negative 2 times 3 plus 12. Okay, this is negative 5 times 6 is equal to a negative 2 times 15. We end up with negative 30 equals negative 30. So we know that it does work, even with the harder examples. Okay, I do hope this helped out.